In today's lesson, we are going to look at periodic behavior. So this is going to be an introduction to a new type of function, even though we've kind of looked at this type of equation or function before, we haven't necessarily looked at it as a graph yet. So before we get into looking at some of the functions, just some key definitions. So if we're looking at periodic behavior or periodic functions, we need to know what that means. And a periodic function is a function that has a pattern of y values that repeats at regular intervals. So this would be basically, we're going to see a repetition in our table of values. Within that repetition, we have a cycle. A cycle is one complete repetition of a pattern. So graphically, we're going to see kind of the same values over and over again. And a cycle is just basically one of those repetitions. The period is the horizontal length of one cycle on a graph, so basically how long one repetition takes, or one cycle. And the amplitude is half the distance between the maximum and minimum values of a periodic function. So just kind of a visual idea. So here we have a periodic function. We can see this repetition, right? We can see it goes up and down, same height, same maximum, same minimum of each kind of wave, so to speak. One repetition, right? If we draw it, right, we can see one repetition of the pattern is here. So the period is that horizontal length. Now, because it's a pattern that repeats, it might be a different pattern or different cycle that we look at, right? So maybe we look at a cycle, say we start here, go up, come down, and go back to there, right? That would be one cycle as well, right? That's one repetition of the pattern. And we would see that same repeat right there. We're kind of going back a bit. We would see that same repeat, right? So it doesn't really matter what we consider one cycle. If we're looking for the period, which we're going to do later on, either way, if it's part of the same pattern, the period should be the same. So that period right here would be the same as the other one that we looked at, right? If it's all part of the same pattern, the cycle might look a little different, but the period should be the same. Amplitude again is from the maximum, so we have our maximum. And we have our minimum, so the amplitude is half the distance between the max and the minimum, right? There is what we call a midline, which is a line that kind of cuts our function in half. And so the amplitude is essentially the distance from the midline to the maximum or the minimum. So what we're going to do first is we're going to just kind of try to recognize some of those properties like the period, the cycle, the amplitude, of our periodic functions in general. So how to find the period of a function. The first thing we're going to do is we're going to choose a convenient x-coordinate. So we're going to find an x-coordinate that is a kind of nice area to look at, especially in terms of a repeating pattern. We want to find a nice value where we can find the next time it gets to that point. So we're going to choose a convenient x value to start at, and then we're going to move to the right, estimate the x-coordinate of where the next cycle begins. Once we have those two x values, we're going to find the difference between them, and that is going to be our period. All right, so let's take a look at a couple examples of finding the period or the length of one cycle. So here we have a function. First thing we want to do is determine if it is periodic or not. So different ways you could do it. You could look at the graph and say, okay, do I see a pattern that is repeating, right? An exact pattern. Sometimes maybe if it helps, you might want to draw it out or sketch what you think one pattern is or one cycle. So I would look there and then there. So I see two cycles of this same pattern, right? I see the same values. If I was to take these marks and I would move them over one another, right? Again, obviously I sketched it. Maybe I didn't trace it properly, but we do see that it's the same pattern over and over again. So this is periodic. The next thing we want to do is find two nice x values, or one nice x value, and then move over to the next one. So I'm going to start right here at 0. right? You could start at 0, you might not. It all depends on the pattern that you're using. And I'm going to take this pattern, or I'm going to take this point, and I'm going to move across horizontally along my x-axis until I find another x value or another point on this function at the same x value, roughly where I think the next cycle begins. Right? So again, you could kind of start to trace it. Right here, we end up back at that same x value, or sorry, y value, that same height, but I'm not repeating my cycle yet. So I'm going to keep on going. Again, I come back to that same value. Haven't repeated my cycle yet. I'm going to keep going. Come back to that value. Okay, that looks like one cycle. Right? So I'm going to look at this x value and this x value. That distance, right? So we're at 0, we end up at 6. So the difference between those two, the period is going to be 6 minus 0, or just 6. And if I look at other values, right, other x values, I do see that if I went backwards 6, I would end up at that same spot as well. And so that would be a distance or a period of 6. Right, so from -6 to 0, right, same idea. Right, still gives me a period of 6. So regardless of what x values we use, right, we should still get the same period because it's for one cycle of the same periodic function. If I look at the next value, or next function, is it periodic? Right, and looking at this, right, if I were to trace it just to kind of help, okay, so I go up to 1 and back down, go up to 2, back down, go up to 1, back down. So maybe I think, okay, there's one cycle. Now I'm starting to go back up to 1 and back down, but now I go up to 3 and back down. Okay, so that's different than what I just did. If you look at the next one, go up to 1, back down, go up to 4 and back down. So if I was to take all of these kind of different repeatable parts and stack them on one another, right, we can clearly see that they're not the same shape. Right, so these are all different. So these patterns are different. Even though they have the same one portion, the rest of it is not the same. So this is not a periodic function. It's not a periodic function because we don't have any repeating patterns. Next, we're going to look at whether a function is periodic or not, and then look for an amplitude. Right? So the amplitude is, again, half the distance between the max and the minimum value. So we're just going to take the maximum value, we're going to subtract the minimum value, and then divide by 2. Right? So we're basically taking half the distance. So I'm going to look at my function here. First, I'm going to check to see if it's periodic. Right? So again, I can pick a value, an x value, and kind of just see, okay, do I have kind of a repeating pattern? So I come back to my starting point in terms of my height or my y values. And as I go through, roughly sketching it, okay, it does look like there's a repeating pattern. So yes, it is periodic. Now you don't have to go through and trace the function and see, right? You should just be able to tell by looking at it if it is periodic or not. Is it the exact same pattern that is repeating? So in this case it is. So next we have to find the amplitude. So the amplitude requires the maximum and the minimum. So I have the maximum here, which is at 3, and I have the minimum here at -1. So therefore my amplitude is going to equal my maximum, so 3 minus my minimum, which is -1, divided by 2. My amplitude is going to be 3 minus -1, or 4 over 2, or 2. So my amplitude is 2. Example 3, now we're going to look for both parts. So first I'm told that it's periodic, so I want to determine the period and the amplitude. So for the period, I need to pick an x value and just kind of estimate my function and keep going until I come back or I think I've done one cycle. So I'm going to start here, right? It's close to 0, it's -1. And I'm going to just trace along just until I come back to that. Okay, so I came back to that point along here. Right, so I came back to that point, but I haven't completed what looks like a full cycle because my function goes down into the negatives first before it comes back up. So my cycle should contain that downward portion. Now I come back up and I'm about to hit the next portion where I start to repeat it. So because it is periodic, right, this is probably one cycle. And if I look back at the other part, right, I can kind of see that same shape again. So again, I'm pretty confident that I have one cycle drawn. So the period is going to be the difference between x values, right? So we're at -1, we end up at 5, so my period is going to equal 5 minus -1, or a distance of 6. So that means that my period is 6 units long. For the amplitude, we want the maximum, so I have my maximum here and the minimum. Now it's going to be the same across every cycle, right? So it doesn't really matter where we look or not, but again, it should be the overall maximum, the overall minimum. So my amplitude is going to equal the maximum, which is 3, minus the minimum, which is -2, divided by 2, because it's half the distance from the max to the min. So we have 5 divided by 2, or we have 2.5. So my amplitude for this function is 2.5. The next thing we're going to look at, if it's a periodic function, we can use our values to help us predict. Right? We can use kind of some values to help us predict the other values in our function. So for the following function, I want to determine f at 2 and f at 5. So this is just looking when x is 2, what is the value of the function. So first one, f at 2, so we go over to when x equals 2. Whatever the y value is our function. So f at 2 is equal to 1. And then f at 5, when x is 5, is 0. Now what I want to do is I want to determine f at 8, f at -10, and f at 14. Now those values are not on the graph. Right, but what we're going to do is we are going to use the period to help us out in this situation. Because the period is the length of one cycle, that is going to kind of tell us when we're going to be repeating our values. So what we're going to do, first we want to know what our period is. So our period in this case is 6 units. So we figured out the period. Next, we want to add or subtract the period of the function until we get back to a value on the graph that we know. Right, so if I look at my graph, I want values that end up either between 7 or -7. But I have to add or subtract the period to get there. So for f at 8, that's going to be the same thing at f at 8 minus 6, or f at 2. Because if I'm at 8, or the f or the value of this function at when x is 8 will be the same for when the function when x is 8 is going to be the same as when the function when x is 2, because it's 1 period apart. So that's when we start to repeat. And f at 2, I can clearly see from my graph, which is 1. Now f at negative 10, I don't want to subtract the period. So I'm going to have to do f at negative 10 plus 6, right? Because I'm going to move 1 period to the right, so to speak. And that'll be f at negative 4. And if I go to my graph at negative 4, maybe let's change the colors here. We'll do kind of a pink. So f at negative 4 is 1. And then lastly, move this over, f at 14. So f at 14 is going to equal f at 14 minus 6. So I got to move to the left, right? I got to move to a period to the left to get closer to 7 and negative 7. So this is f at 8. However, this one's okay. I don't need to go further because I already found out what f at 8 is, which was 1. So the function at all 3 of these x values is going to equal 1. Next, for C, now we're going to find 4 values of x that give us a function or a value of the function of 2. Right, so first what I have to do is I have to add or subtract the period value to the original x value, right, where y is 2. So first I need to look at my graphic and say, okay, when is the function equal to 2? If I look at the function, right, we see the function is equal to 2 at 0 when x is 0. Right, so f at 0 equals 2. So now what I have to do is basically just add and subtract the period, which we know was 6. So add and subtract the period to this x value, and that is going to give me other x values of this function that equal 2, or where it equals 2. So for example, f at 0 plus 6 equals 2, or f at 6 equals 2. Let's just take a look at our graph just to double check that. And if I look at f at 6, we do see that the function is equal to 2 there. So I can keep on going even if it's not on the graph. So I could take f at 6 plus 6 is going to equal 2, because again, I'm adding a period. I'm going 1 period over. So I get f at 12 is equal to 2. I could keep on going. So we could have f at 12 plus 6 equals 2, or f at 18 equals 2. I could go again a bit further, or I could subtract, right, and go backwards. Again, different ways that we could do it, right? We could keep adding 6. So from 18 it goes to 24. From 24 it goes to 30, or we can go backwards. So from 0 we go to negative 6, then negative 12, negative 18. Right? As long as we're adding that period to each value, or to each x value, that's going to move us 1 period or 1 cycle away, which brings us to back to that same y value. Last example, so a cutting machine chops strips of plastic into their appropriate lengths. The following graph shows the motion of the cutting blade on the machine in terms of time. So we have our our function mapped out. First thing we want to do is state the maximum height of the blade, the minimum height, and the amplitude. So looking at this, we can see that our maximum is at 0.5 centimeters. Our minimum is down here, so when it drops to the bottom, our minimum is equal to 0 centimeters. And then the amplitude is going to equal the maximum minus the minimum divided by 2, or 0.25 centimeters. B asks, what is the period of this function? Right, so the period of this function, again, if we look at, we could take two values and see where it starts to repeat. Right? So we could pick right here, which is right after it comes up. So it goes over, the blade goes down, comes back up. That's one period. So from here to here is a period. And if we take a look at the x values, that goes from 4 to 8. So the period is equal to 8 minus 4, which equals 4 seconds. So the period is 4 seconds, or it takes 1 second, or sorry, 4 seconds to repeat the cycle of chopping or cutting the plastic and then coming back up. C says, state the next 2 times the blade will strike the cutting surface. So I need to first look and see, okay, when does it strike the cutting surface? When does it hit, or when does the height equal 0? And I see 2 values, right? We see one here and we see one here on our graph. Right, so I'm going to pick the farther, or the most recent one, or the latest one, which is when the function is 7.5, the height is 0. Right, so we see this last one over here. When a time of 7.5, or an x value of 7.5, the height is 0. So that means it strikes the cutting surface. Now I need to find the next 2 times. So the next 2 times are going to be the next cycle over. And I know how long a period is 4 seconds. So my next one is going to be f at 7.5 plus 4, and that will give me a height of 0, or f at 11.5 equals 0. The next time, after that, for the second time, it's going to be f at 11.5. I'm going to move 1 period over, or 4 seconds, and that will give me a value of 0. So when f is 15.5, I get a y value of 0, or the function equals 0. So therefore, the next time the blade is striking is at 11.5 seconds and 15.5 seconds. So this lesson, again, was just an introduction to periodic behavior, or periodic functions in general. Again, looking at some key terms: amplitude, max, min, period, cycle, what a periodic function looks like in general. Because as we go through, we're going to get more specific, and we're going to focus on 2 periodic functions in particular.